So for my chemistry project, I chose to do a video, and I'm going to focus on reactions as well as balancing equations. So this is going to cover the five main types of reactions, and this includes synthesis or combination, decomposition, single displacement, double displacement, as well as combustion. They're kind of in the order of easiest to hardest for what most people consider them. Next, we're going to move on to 4 practice problems after that, and we're going to utilize 4 of the 5 reaction types, and then we're going to start with English, and we're going to change that to a chemical formula, and we're going to balance that, and then decide what type of reaction it was. So let's start. So let's start with the different types of reactions. First, we're going to start with synthesis. Now, this is also called a combination reaction for some people, and it's generally the easiest because synthesis is basically combining 2 things to get to 1. So when you do your reaction or project or whatever you're doing, you'll start with 2 different ingredients or reactants, and you'll end with this because they combine to form 1 thing. Next, let's move on to decomposition. Decomposition is basically the opposite of synthesis because you're taking 1 thing and breaking it into 2. Now this is like kind of a inverse of this because you're starting with A and B combined and you're ending with them separate. You're starting with 1 reactant and 2 products. Next, we're going to go to single displacement. This is where it starts to get harder and people tend to think it's harder. So for single displacement, it would be thought of as AB plus C results in AC plus B. So if you look at it in this way, you'll start with this, and this will get combined with it during the reaction, and this will kick this out. So as you can see, we start with AB, but we end with AC, and B gets kicked out by C over here. They switch spots. Now let's move on to double displacement, which is like that, but a little bit different. So for double displacement, it's easy to think of it as this. So you have AB plus CD results with AD plus CB. So the reactants kind of flip-flop. So A is at first with B, but it switches to be with D. And while B is with A, it switches over here to be with C. So they kind of switch places, and it results in the products being kind of mix-matched versions of the product or the reactants. And now let's move on to the final one that we're going to speak about, and that is combustion. And this can be thought of different reactions that require heat and heat energy and fire. So this is how it can be written out. So first you start with a hydrocarbon, and now you can have X amount of carbon and Y amount of hydrogen. It doesn't really matter, and it can be whatever number. In one of our examples, we'll use pentane, which is a hydrocarbon. So you take the hydrocarbon and you add oxygen, which is a diatomic molecule, I guess. And when you add those together, you get carbon dioxide, CO2, and water, H2O. Now, when you are balancing this, it'll be dependent on these 2 numbers to make sure it's all balanced out right. So let's move on to the different practice problems that we have. So first, since we're going to start in English, here is our first equation, or first English sentence. And it's pentane plus oxygen is equal to carbon dioxide plus water. So since, without even thinking about these, we can look at these 2 and know that this is a combustion reaction because you result with carbon dioxide and water. So let's see what pentane is plus oxygen and see the result. So the initial chemical formula we'll start with is C5H12 plus O2 results in CO2 plus H2O. Now that's written out correctly, but we have to balance it. So this will be a 2-step balance. And to start, we can add a 5 to the carbon dioxide as well as a 6 to the water. Now this 5 makes it so that there's 5 carbon, which we have over here, and over here there's only 1 carbon. Now this also results in 10 oxygen because you'll multiply this number by this number. So this results in 5 carbon and 10 oxygen. So you have the 5 carbon complete. There's 12 hydrogen over here still and 2 oxygen. Now with this 6 as the constant in front of the water, it'll result with us having 12 hydrogen, as we can see right here, because 6 times 2 is 12. So this automatically balances with that. Now this 6 also carries over to this oxygen, so it'll be 6 oxygen, whereas we only have 2 over here. That is where the next step comes in. So the next step to this one, and the final one, this is the final balanced equation, is adding an 8 in front of the oxygen on this side, because that results in 16 oxygen, which is what we created over here, because 6 times 1 is 6, and 5 times 2 is 10, so 10 plus 6 is 16, which is 8 times 2. Now that's finally balanced. And like we said earlier, since there's a hydrocarbon and oxygen, and we result with carbon dioxide and water, that is combustion. Now let's move on to our next example. This one is a little bit trickier, but it really isn't when you work it out. So we have zinc plus hydrochloric acid results in zinc chloride and hydrogen. So to write this as a standard chemical formula, it'll be zinc, Zn, plus hydrochloric acid, HCl, and that results in ZnCl2, which is the zinc chloride, and H2, which is the hydrogen, and it's a diatomic atom, so it has to be a 2. And we have to think about that when we're balancing it. So this is only one step to balance, and it's pretty easy. So we can look at it like this. So we'll keep 1 zinc, because we only have 1 over here. And by adding a 2 to this hydrochloric acid, HCl, we get 2 hydrogen and 2 chlorine, which we have over here. So we have 1 zinc, 2 chlorine, and 2 hydrogen, which is on both sides. So that's finally balanced. And this one would be a single displacement reaction because we have the AB plus C over here and AC plus B. So yes, single displacement. Next we'll move on to this one. So our English for this one is octasulfur plus fluorine results in sulfur hexafluoride. So we can already tell that this is going to be a synthesis reaction because it's 2 things going down to 1. So to write out the initial equation, we'll have S8, which is octasulfur, and F2, which is fluorine, and it's diatomic. So that results with us having SF6, which is sulfur hexafluoride. The next step in this would be to add an 8 in front of that sulfur hexafluoride. This results in 8 sulfur, which is equal to over here, but it also results in 48 fluorine. So 8 times 6 is 48. Now we only have 2 over here still, so we're going to have to think of a number that we can multiply that 2 by to get the same 48 of fluorine that we have over here. So that's pretty simple, and we are left with 24 fluorine, which is the 2, so 24 times 2 is 48, which we have over here, and 8 sulfur, and we are done. And like we said earlier, synthesis reaction. Our last example, and arguably the hardest, will be iron 3 chloride plus ammonia goes over to iron 3 hydroxide plus ammonium chloride. So the first start, we have to start by writing this out, and it's definitely going to be a little trickier. So we have FeCl3, which is the iron 3 chloride, and the 3 correlates to there. And then we have ammonia, which is NH4OH, and that results in FeOH3, which is the iron hydroxide, and since it's 3, we have the 3. And then ammonium chloride, which is NH4Cl. So to begin balancing this, even though it looks menacing, it's actually pretty easy. So first we can add a 3 to the ammonium chloride. And since we do that, we will have 3 nitrogen as well as 12 hydrogen. And we only, on this side, we only have 1 nitrogen and 4 hydrogen still. But in our next step, that'll get fixed. This also results in us having 3 chlorine, which we have over here. We still have 1 iron over here, so that's still balanced. We're not going to mess with that yet, or at all. And then the next step is adding a 3 over here. Now that balances our nitrogen and hydrogen, and our OH also, because there's 3 over here, and we just added a 3 over there. And since our chlorine's already balanced, and there's only 1 iron on each side, that's balanced. So, because these are an AB and a CD, and they flip-flop over here, this is a double displacement reaction because these two join together as well as those two, and it creates the opposite versions of those. So this is double displacement. Thank you for listening.